Welcome to the YouTube channel for Dataflow Geometry. I'll be your tour guide. I'm Tour Guide F. Well, what do we do here? Dataflow Geometry is a learning portal for those interested in math with computational thinking. This is 21st century math. So what do we mean by that? Well, what we're going to do is restudy geometry from the standpoint of having all our arithmetic done automatically by the computer, where you, the problem solver, occupy a higher perch where you delegate all of that number crunching in your design to solve each problem. Well, how did I get here? I spent most of my career here in Silicon Valley developing scientific software. And what I discovered was that the geometry education I was given in high school was highly inadequate for understanding how to solve geometry using software. And that a new set of concepts would be needed to apply to this problem of having the computer do all the numerical work for me. Well, let me show you an example of that. So you've got two circles, and the problem is to figure out when the circles are overlapping where these two intersection points occur. So let me break it down more as a number crunching problem. So the givens that you have to work with are the following. So you're given the x and y pixel coordinates for the center point of the orange circle. You're given this distance in pixels, which is the radius of the orange circle. You're given the same information for the red circle, so its center location is two numbers and its radius is a third number. So your inputs, you have 6 numbers altogether. And what you have to do in terms of number crunching is to turn those 6 numbers into 4 numbers, which are the x and y pixel coordinates of this point here and of this point here, the second intersection point. Now, when I first developed the algorithm, it didn't have any graphics, so it was really kind of hard to convince myself it worked. So I set out to develop the 2D graphics that we're looking at right here, and the mouse editing operations to do this dragging of the circles. And when I got this all working, and I could see that my algorithm was working correctly, and in fact was coughing out dozens of correct solutions per second, something was born in that instant. I started asking myself, why isn't geometry being taught this way? We have the tools, people have computers. What's the problem with getting this new information out there to people? And that led to forming a skunkworks. We went out to the public schools. We taught for 2 years a course called algorithmic geometry. It was taught with the Java programming language as the tool. And you're going to be learning the same concepts we taught in that course, but there'll be no Java programming. So we've completely eliminated Java programming. You don't need to use it. We're going to teach you a much easier system for delegating your work to the computer. Here's an example. And we've gone the last mile to make sure that everything about the software you'll be using is fully supported with the appropriate training, guidance, references, so that you can study on your own and be confident you won't be getting stuck. So what types of things would this apply to studying Dataflow geometry? Well, if you have any interest in any of the spatial technologies of the 21st century. So those could be things like CAD, GPS positioning, robotics, molecular design, architecture, protein design, any of these topics, navigation, mobile robotics, all of these topics have one thing in common, and that they're based on geometry with computational thinking. And that's what we can help you with here. So that's my pitch. You're probably asking yourself, do I know enough math to study this Dataflow geometry with computational thinking? Well, it's a very fair question. And what we've done is designed a 5-question readiness quiz, and this will help you decide whether this would be a good effort for you at this point. And I'll see you in the next video, and we'll go over the quiz questions.